But it is possible that some new form of particle, something else, could be discovered.
Yeah,
that we don't know about yet.
Because we almost know that there are other particles out there in the universe.
We almost know?
So a thing called dark matter.
Yes.
So we look out into the universe and we see that there's a lot of stuff there that's interacting gravitationally.
What you're about to see is not science fiction. The James Webb Space Telescope has just captured an image so breathtaking, so mind-blowing, that it's left scientists speechless and the internet stunned. What did Webb just discover? And why is this image rewriting what we thought we knew about the universe? Buckle up, because this changes everything. This is one of the most astonishing views of the cosmos ever captured. The Sombrero Galaxy, also known as Messier 104. Located 28 million light-years away, this galaxy has long fascinated astronomers with its enormous glowing core and its distinct wide-brimmed dust lane, earning it the nickname Sombrero. But this new image from Webb reveals something never seen before. For the first time, we can see beyond the thick bands of dust that obscure the galaxy's center, exposing hidden structures, clusters of newly formed stars, and possibly even new clues about the supermassive black hole lurking at its heart. Compared to previous telescopes, Webb's infrared vision pierces through the darkness, unveiling details that were once invisible. Scientists are now re-examining this mysterious galaxy, questioning its evolution and the role black holes play in shaping galaxies. The Sombrero sits at the crossroads of a long-standing mystery. It is classified as a lenticular galaxy, a hybrid between spirals like our Milky Way and ellipticals. This new image could be the key to understanding how galaxies transition over billions of years. Beyond just the stars, this image reveals the intricate structure of cosmic dust, more than just an obstruction to visibility, but a fundamental ingredient in the birth of stars and planets. The Sombrero's dust lanes appear far more structured than those in typical spiral galaxies, hinting at a unique evolutionary path. Could this be evidence of past galaxy mergers, or hidden star clusters that defy our understanding of galactic history? At its very core lies something even more fascinating, a supermassive black hole, estimated to be 1 billion times the mass of our Sun. Astronomers have long known of its existence, but this new image offers an unprecedented opportunity to study how it interacts with the galaxy. Is it actively consuming matter? Could it be influencing the Sombrero's distinct structure? Webb's observations may finally provide answers. And there's something even more profound to consider. The light from this galaxy began its journey 28 million years ago, long before human civilization even existed. Looking at this image is like traveling back in time, witnessing a moment in cosmic history that no longer exists. But beyond its past, this image may also hint at the future. Could our own Milky Way one day resemble the Sombrero? Will our central black hole shape our galaxy in a similar way? One thing is certain, this discovery is just the beginning. With every deep space observation, Webb is rewriting the story of the cosmos, revealing details hidden from us for eons. What other secrets are waiting to be uncovered? One thing is for sure, with the James Webb Space Telescope, we are only scratching the surface of what lies beyond. One of the most striking examples of Webb's ability to unveil the unseen lies in its recent observations of the Sombrero Galaxy. By comparing Webb's view with Hubble's, we gain a deeper understanding of how different wavelengths of light reveal entirely new aspects of the cosmos. The differences between the James Webb Space Telescope, JWST, and Hubble Space Telescope images of the Sombrero Galaxy, M104, lie in their wavelengths, level of detail, and the features they reveal. Hubble's image, taken in visible and near-infrared light, showcases the galaxy's striking, nearly edge-on dust ring with remarkable clarity, highlighting the bright, bulbous core and the dark, obscuring dust lane that gives the galaxy its namesake appearance. The image presents a well-defined, glowing central bulge composed mostly of older stars, contrasted against the dark, cold dust that forms a nearly perfect silhouette. However, despite its incredible sharpness, Hubble is limited by the wavelengths of light it captures, which primarily show the galaxy's starlight and some hints of the structures within the dust lane. In contrast, JWST's infrared capabilities penetrate the thick dust, revealing a far more intricate structure hidden beneath the dark band seen in Hubble's image. The mid-infrared instrument, MIRI onboard Webb, captures the warm glow of dust grains, unveiling complex, web-like filaments of interstellar material and star-forming regions previously obscured. This provides a striking contrast to Hubble's image, where the dust lane appears as a solid dark streak. In JWST's view, it becomes a vibrant, detailed region filled with complex activity. Furthermore, JWST's observations of the Sombrero Galaxy bring out the presence of polycyclic aromatic hydrocarbons, PAHs, organic molecules associated with star formation, scattered throughout the disk, features that were barely perceptible in Hubble's optical view. Additionally, JWST's ability to detect cooler, older stars in the near and mid-infrared makes the galactic halo appear more extended and populated with subtle structures, hinting at possible past interactions or accretion events that shape the galaxy's evolution. This is in stark contrast to Hubble's optical image, where the halo appears more uniform and less detailed. Another critical difference is Webb's ability to probe deeper into the central region, revealing previously hidden structures surrounding the supermassive black hole at the galaxy's core. Hubble captures the brightness of the galactic nucleus, but struggles to see through the dense central regions, whereas JWST peels back layers of dust, exposing swirling material and faint structures hinting at active processes near the black hole. The combination of these differences means that while Hubble presents the Sombrero Galaxy as an elegant, dust-draped spiral, Webb transforms it into a dynamic, textured system full of hidden complexity. The striking contrast between these images emphasizes how different wavelengths of light reveal vastly different aspects of the same celestial object, with Hubble offering a crisp, luminous view dominated by stars, and JWST providing a deep, infrared perspective that uncovers the hidden machinery of dust, gas, and ongoing star formation within the Sombrero Galaxy's iconic structure. However, another study comes to light. Dark matter is one of the greatest mysteries in astrophysics. Though it makes up roughly 85% of the universe's total mass, it remains completely invisible, detected only through its gravitational effects. Galaxies like the Sombrero provide key opportunities to study dark matter because their structure and motion can reveal clues about this unseen force. While we cannot directly observe dark matter, astronomers can infer its presence by studying how galaxies rotate, how their mass is distributed, and how they interact with their surroundings. The Sombrero Galaxy, with its massive central bulge and thick disk of stars, presents an intriguing case, one that may challenge or refine our understanding of dark matter's role in shaping galaxies. One of the biggest indicators of dark matter in any galaxy is its rotation curve, the way stars move around the center. If only visible matter influenced galaxy rotation, we would expect the outer regions to move more slowly, much like how planets farther from the Sun orbit more slowly due to weaker gravity. However, observations of many galaxies, including spirals and lenticulars, show that stars in the outer regions rotate at nearly the same speed as those near the core. This suggests the presence of a hidden mass, a dark matter halo, extending far beyond what we can see. While past studies of the Sombrero Galaxy have suggested that it may contain a significant dark matter component, Webb's new data could provide a much clearer picture of its distribution. One aspect of the Sombrero that makes it particularly interesting in the dark matter discussion is its unusually bright and massive central bulge. The mass concentration in this region is extreme compared to typical lenticular galaxies, leading to questions about how it formed. Did a past merger funnel large amounts of matter into the center, or could an unseen dark matter core be contributing to its mass? If dark matter is present in high concentrations near the core, it could have influenced the way stars and gas settled into their current arrangement. Additionally, if Webb's observations reveal unexpected gravitational lensing effects, subtle distortions of light caused by massive unseen structures, it could indicate that dark matter is playing a larger role in the Sombrero than previously thought. Another approach to studying dark matter in the Sombrero is analyzing how its dust and gas behave. Dark matter does not interact with light, but it does exert gravitational influence on normal matter. If Webb detects unusual motion in the gas clouds surrounding the galaxy, such as regions moving faster than expected or behaving in a way inconsistent with visible mass, This could be further evidence of dark matter's presence. Additionally, if the sombrero experienced past interactions with smaller satellite galaxies, astronomers could analyze how those interactions played out. If a satellite was drawn in by the sombrero's gravity and moved in an unexpected way, it could reveal hidden mass distributions consistent with a dark matter halo. The Sombrero Galaxy provides a unique laboratory for studying dark matter because of its hybrid structure. It shares features with both spirals and ellipticals, meaning it may contain clues about how dark matter behaves in both types of galaxies. If Webb's observations confirm the presence of a dark matter halo around the sombrero, it could help refine models of galaxy formation and evolution. On the other hand, if the galaxy's mass distribution deviates from expectations, it may challenge existing theories about how dark matter shapes galaxies. Either way, uncovering the secrets hidden in the sombrero could bring us one step closer to solving one of the universe's greatest enigmas. While dark matter's gravitational presence may be holding the galaxy together, another powerful but hidden force lies at its heart: the supermassive black hole. If dark matter shapes the large-scale structure of the sombrero, the black hole could be playing an equally crucial role in shaping its inner regions. Supermassive black holes are some of the most influential forces in the universe, capable of shaping the fate of entire galaxies. The one at the center of the Sombrero Galaxy, estimated to be around 1 billion times the mass of the Sun, is particularly intriguing due to its size, location, and uncertain level of activity. While most galaxies of this type either contain highly active black holes or ones that are completely dormant, the Sombrero's central black hole appears to exist in a puzzling middle ground. New observations from the James Webb Space Telescope, JWST, could finally help astronomers determine whether this black hole is quietly influencing its host galaxy, or if it once played a much more disruptive role in its evolution. One of the biggest mysteries surrounding the sombrero's black hole is whether it is currently accreting matter. Active black holes pull in surrounding gas and dust, forming a superheated accretion disk that emits massive amounts of radiation, particularly in the X-ray and infrared wavelengths. However, previous observations, including those from the Chandra X-ray Observatory, have detected only weak X-ray emissions from the sombrero's core, far less than expected for a black hole of this size. This raises an important question. Has the black hole run out of material to consume, or is it feeding in an unusually inefficient way? If JWST detects subtle infrared signatures of warm dust spiraling toward the center, it could suggest that the black hole is still slowly consuming material, just at a rate too low to produce intense emissions. Another possibility is that this black hole was once far more active in the past, releasing powerful bursts of energy that reshape the surrounding galaxy. Some black holes, during their most active phases, can generate enormous winds and jets that push away gas and prevent further star formation. If the sombrero's black hole had a similar past, it could explain why the galaxy has such a massive, bright central bulge but relatively low levels of current star formation. Traces of this past activity might still be present in the form of shock waves or unusually heated gas, which JWST could detect in the infrared spectrum. If such remnants exist, they could provide insight into how black holes regulate star formation and influence the structure of their host galaxies. The interaction between the black hole and the sombrero's unique dust ring is another area of interest. Unlike the well-organized spiral arms seen in other galaxies, the sombrero has a thick, structured ring of dust encircling its bright core. One theory is that this ring could be fueling the black hole, slowly funneling material inward. However, if JWST's observations show that the dust is stable and undisturbed, it could suggest that the black hole has been inactive for an extended period. This would make it an unusual case compared to other galaxies with similar mass distributions, challenging current models of black hole galaxy coevolution. Ultimately, studying the sombrero's supermassive black hole isn't just about understanding a single galaxy. It could provide crucial insights into how black holes grow, evolve, and interact with their surroundings. If JWST's data reveals signs of hidden activity, it could suggest that many other quiet black holes across the universe might also be more dynamic than they appear. On the other hand, if this black hole truly is dormant, It might force astronomers to reconsider the relationship between galaxies and the enormous gravitational engines at their cores. One of the most profound aspects of studying black holes, like the one in the Sombrero Galaxy, is that they are not just isolated phenomena. They are deeply intertwined with the grand narrative of cosmic evolution. Understanding their behavior helps us piece together the intricate relationship between matter, gravity, and time itself. But beyond the physics of black holes and galactic dynamics, there is an even greater story unfolding. A story written in the light that has traveled across the universe for eons, carrying with it the echoes of creation itself. As we peer deeper into the cosmos, we are not just uncovering the secrets of distant worlds. We are witnessing the echoes of creation itself. Each beam of light that reaches our telescopes has traveled across the vast, silent expanse of space for millions or even billions of years, carrying with it the untold stories of ancient stars, long extinct galaxies, and the very birth of the universe. The James Webb Space Telescope, with its unparalleled vision, is not merely an instrument of observation. It is a time machine, revealing a history written in stardust. Every image it captures is a bridge between the past and the present, a testament to the immense scale of the cosmos and our tiny but extraordinary place within it. When we look at these celestial relics, we are confronted with a paradox. The farther we gaze, the older the light. And yet, in those distant fires, we see the raw materials from which we were forged. The same atoms that once burned in the hearts of primordial stars now course through our veins, binding us to the universe in ways more profound than we can fully comprehend. And so, as we stand on this small, fragile world, staring into the abyss of time, we are reminded that we are not separate from the cosmos. We are part of its grand, unfolding story. What new wonders await us in the infinite darkness? What answers lie hidden in the shimmering remnants of the past? With every discovery, we step closer to understanding the greatest mystery of all. Not just where we came from, but what lies beyond the edges of the known, waiting to be revealed.